to a function prime, the derivatives. Okay, so e to the x is the simplest possible function to differentiate. It's simply e to the x. There is no other function, a general function. We may find something that is identical when we differentiate it with its function, but this is the generic function, that one of the pure functions that has, the only one that I can think of, e to the x prime equals e to the x. But now, if you remember, I didn't tell you the whole story. And the whole story is e to the x prime is e to the x times the inner function prime. How come that I did not put that in? Can anyone refresh our memory why we did not put that in?
Because it's 1.
Because it's 1. X prime is 1. But now this makes it easier for e to a function prime. What do you think the formula would be, which is the chain rule? What do you think the formula will be for this? You just have to mimic this. You just have to tell me what to write. Who would like to try? Yes.
E to the f of x and then times f of x prime.
We have no choice. Thank you so much, because this is a function. And you can say, but x is a function. Yes. But when we say f of x, we really mean anything but x, plain x, because there is no need. This will be 1. Okay, so let's practice now. Choose any problem you want. Any problem you want from, first, let's look at 1 through 24. 1 through 24. If you don't choose, I will.
Can we do 7?
Good. Let's start with 7. In 7, we have a g of x equals x to the 5th times e to 2x. Very good pick. Remember, when we are asked to differentiate, we have to be careful. We have to analyze and see what's going on. And I do analyze, and I see what's going on, and I see it's a product of 2 functions. Please remember, the product of 2 functions prime is not f prime times g prime, as I saw in some of your work. Please. The formula one more time is 1 times 2 prime equals 1 prime times 2 plus 1 times 2 prime. You can twist it the way you like, but that's the formula. So therefore, g prime, can anyone help with g prime? Anybody, please. So g prime of x will be anyone, please?
5x to the 4th.
Very good. Times the second function plus the first function times the second function prime. And please remember, this is the formula. E to a function prime is e to a function times the inner function prime. How do I write that? Can anyone differentiate e to 2x for us?
Would it be e to the 2x times 2? Or
That's
2?
it.
Yeah.
That's it. That's it. You can further simplify this a little bit by factoring out e to 2x and x to the 4th, but let's see it first. 5x to the 4th plus 2x to the 5th. So these are easier somewhat to simplify a little bit. So I will also factor out x to the 4th. So x to the 4th e to 2x and then I have 2x plus 5. Again, I factored out this, and then I wrote 5x to the 4th plus 2x to the 5th. X to the 4th and x to the 5th have a common factor of x to the 4th. And I put this one first and this one second in descending order. Let's see if we have any questions on this problem.
Do we have to fully simplify, or can we leave it
Um,
like we did
in certain
the last
situations, in chapter 3, will be mandatory. If something else follows, the answer is yes, we have to. Good question.
Okay, thank you.
Thank you. Okay. I don't want to differentiate the second. This is too much. Not these type of functions. Unless you want to choose one, I'm more than happy to show. But let's choose something else. Maybe a radical, maybe a ratio. But if you want to choose a second derivative, I'll be more than happy to work on one. It's up to you.
Can we do 16?
Yes. 16. Very good. In 16 we have y equals the square root of e to the x plus 1. It's a very good one because I want to refresh your memory that with the formula, y prime is 1 over 2 the square root times the inner function prime. So this is very important. This is a very important formula. If you remember, the square root of a function prime is 1 over 2 the square root of the function times the function prime. Please do not forget this formula. This is a very important formula. Let's also look at the ratio. Any questions on this? Any questions on this? Do we remember this formula? Any questions, please? Okay. So let's also look at the ratio. I don't know, 23. In 23, we have r of t equals t squared plus 2t divided by e to t squared. And then I like to look at a word problem. So r prime, I have to use the quotient rule. And I have to square the denominator. When I square e to t squared squared, I get e to 2t squared. Copy the base, multiply the exponents. But now the numerator is more complicated. Can anyone give us the derivative of this? So I can put it here. And then multiply by e to t squared minus. Then the top times e prime, e to t squared prime. So can anyone give us a derivative of this, of t squared plus 2t, so I can put it here? So remember the formula. 1 over 2 prime equals 1 prime times 2 minus 1 times 2 prime over 2 squared, not prime. So I need to differentiate this and put it here. Can anyone give us the derivative of this? Please.
Do t
Yes.
plus 2.
Yes, this is it. Perfect. Excellent. Now, so I have this. I have times 2. I copy the negative sign. I copy the top one. And now I have to differentiate this and put it here. And that's it. So can anyone differentiate this for us and put it here? It's e to a function, everything prime. Can anyone differentiate e to t squared so I can put it here, please? Anybody? Please.
Would it be e to t squared
Times?
times 2t?
Yes. E to t squared times the inner function prime, which is 2t. Yes, we can clean it up by factoring, distributing. Yes, it's possible. Good. Let's look at the word problem. Any questions? Okay. Let's look at the marginal cost in millions of dollars. And remember, marginal cost is the name of C prime of the function. So this is 47 on page 210. Marginal, we talked about marginal cost, is C prime of x. Good. So they're giving us C of x, which is 100 minus 50 e to negative x. X is the number of houses built, and C is in millions of dollars. They also graph the function for us. Find the marginal cost, find the marginal cost at 0, find the marginal cost at 4, and then some limits. Okay? So first let's find the marginal cost function, and then plug in 0 and 4. Good. So C prime of x, and then C prime of 0, and C prime of 4. Can anyone help with C prime of x? C prime of x. How much is 100 prime?
0.
Perfect. Now I have negative 50 times this function prime. It's e to a function prime. What do we get? E to a function prime. Is e to that function times the inner function prime, which is
Negative 1.
-1. So this is 50 e to negative x. This is the function I need to put in the calculator and then plug in 0 and then plug in 4. 0 is very easy, but let's put it in. So this is 50 e to negative x in y equals clear 50 e to negative x. Okay, and now I plug in 0, which I know it's going to give us 50. And the other one, I plug in 4. And we got 0.92. The measurement unit. Remember, the measurement unit is made of two pieces, because this is the rate of change. C was in millions, and this is per unit. So X is number of units, C is in millions. So it's always the Y variable, the measurement unit of the Y variable, over the measurement unit of the X variable. So this is the million per unit. So when we manufacture 0, 50 million per unit. When we manufacture 4 units, the rate of change of the cost is $0.92 million per unit. Now, they also ask us to determine two limits. Let's determine the first limit. So they say, find the limit as x approaches infinity of c of x. And you have it here because they're showing us the graph. What will be the limit? Look at the graph. Limit of c of x as x approaches infinity. What will you say? Based on the graph. As x approaches infinity, the function values get closer and closer, closer and closer, closer and closer to what?
100.
Exactly. This is the horizontal asymptote. Okay? 100, I think it was it 1,000 in millions of dollars? Okay, and then here they're asking us to run to the nearest 1,000. So we should say 920. Fine. So we can say here 920 because they want us to multiply by 1,000. Okay? Why they want that? It's not clear to me. Good. They also want us to determine the limit of c prime when x approaches infinity. So when x approaches infinity, remember this approaches 0. And 0 times 50 is 0. Very easy to put in the calculator if you want to convince yourselves or if you want to check. Very easy, put the derivative function in the calculator, which is, oh, I already had it. I just should have not deleted. Okay, good. So if you want to convince yourselves, just make x bigger and bigger and bigger and bigger, and we already have the answer. So the limit is 0. If you want to put 50,000, 500,000, it's still going to be 0. So the limit is 0. Here, it tells us that as the number of units increases without bound, which is not really possible, then the limit of the cost will be 100,000. Now here it says that the rate of change as x increases, in other words, as we manufacture more and more and more and more units, the rate of change of the cost will be 0. It will not change. It will stay the same. No change. That's all it means. Any questions on this problem? Should we look at another? Should we look at another word problem? Is that a yes? Is that a no? Anybody? Okay. So maybe we should look at medication concentration. Okay. The concentration C in parts per million ppm of a medication in the body T hours after ingestion is given by the function. So we have to take a medication and they determine a function C of T that gives concentration in the bloodstream in ppm, parts per million, T hours after ingestion. Find the concentration after 0, 1, 2, 3, and 10. So 0, 1, 2, 3, and 10. We can use the graph to look at the graph between 0 and 10. We can do that. But then they're asking us to find graph between 0 and 10. And then they're asking us to find, to discuss C of 5 and C prime of 5. Good. So first of all, we have to find C prime, because that's the question. The question says, find the concentration Okay, no, find the concentration and then later on find C prime of 5. So we have, let's find the concentration first. So I'm going to create a little table so I can organize the information very nicely. So I have T, 0, 1, 2, 3, 5, and 10. Why 5? Because they also want this. So I have C of T, and then I'll have C prime of T. Okay, so let's find C prime of T. So we have it ready. Can anyone tell us which formula we apply for C prime of T? It's 10t squared times e to negative t.